Hello everyone, welcome to this video, the first video actually on algorithms and complexity, or better known as the famous data structures and algorithms. Right? If you're watching this video, I'm assuming you've already cleared discrete mathematics. In that case, well, you can take a few minutes to just clap for yourself. You've been through a lot, but I'll promise you you'll be through way more this year, sadly. Yeah, so I'm pretty sure coming into CS you've been hearing a lot about this data structures and algorithms, saying know your data structures, know your algorithms, know your what, etc. Right? But before we get into the fancy stuff that I know you've been hearing about, like trees, right, the lists, queues, stacks, etc. Before we get into all that, we need to do a bit of math. I mean, this is a math course, but yeah, we're gonna have to do a bit more math. And hopefully doing this will actually give us a foundation of where we're going. Right now, this math, luckily, it's just a review of the math you were doing last year. Right, it's just a review of discrete math, right? Of course, with a few things that we're going to add on top of it. But yeah, the first thing we're going to discuss, right, is exponents. Right, we've been doing exponents from, I think, grade 9. I don't know, I didn't enjoy my time in high school that much, so I don't remember a lot, but I think we started doing these in grade 9. So exponents, right, the famous exponents, very simple, and I'm just going to list up a few rules. So we have a to the power x, then b to the power y. You can just say this times a to the power y. This is the same as us saying a to the power x plus y, right? Just those rules of indices that we know. A over x over a over y is equal to a x minus y, and we have a x y. I'm pretty sure you can fill these guys in, right? I'm pretty sure you can fill these guys in. Now we have a to the power x plus a to the power x, which is just 2a to the power x, and so on and so forth, right? If you have, let's say, 2 to the power n to the power m plus 2 to the power n, this is essentially equal to 2 times open brackets 2 to the power n, which is just 2 to the power n plus 1. Yeah, simple stuff like that. But what does this get us? Well, we continue actually. Yeah, there's still a lot more that we need to cover. We continue on to the next one, which is logarithms, right? Logarithms. Now again, we have the rules of logarithms that I won't really get into much, but one thing I am going to get into is proofs. Yes, proofs are back. You cannot run away from proofs, sadly, in CS. We're going to be doing them. I think we're even doing them in artificial intelligence. So you'll still have proofs. And we're going to start off logarithms with a proof. Less than 5 minutes into this video and we're already doing math. It's very good. So, the first logarithm, right? One of the rules of logarithms that we know is that if we say log base a of b is equal to log base c of b over log base c of a, right? We already know this one, where if we can get these two like this and then multiply them by the base. This is like a general rule that we know, but then there is a proof, and the way we're going to do this proof is how you're going to be doing all the proofs for this one, right? This is how you're going to be doing all the proofs for logarithms, so you should really pay attention to what I'm about to do next, right? So as we keep on going, of course, I'm going to, I think I'll just do all the proofs for this one and then move on to the next topic, because this is a topic on its own, at least. So how are we going to do this proof, right? So we're going to apply the rules that we know for logarithms. First of all, we can assume, right? So we start our proof. So we assume z is equal to log a log b base a. And one thing you need to remember whenever we're dealing in algorithms and data structures, when we say log, right, when you mean log, it's actually log base 2, right, or whatever is here. It's not log base 10, right? This is not the case, right? This is not the case. Don't do this. Whenever you see log, always remember that's log base of 2. Right, that's one thing you should always remember. We just don't include the base, but in computer science it's always base 2, not base 10 like in conventional mathematics. So we're going to have that, then we're going to say x is equal to log c of b, and then y is equal to log c of a, right? Okay, good. We have this simple one, right? We have this simple proof, and then what we're then going to do is we're going to apply the rules that we know, right? The rules that we know of these exponents that we're doing. So what we can do is that z is equal to log whatever, that one can actually just become a to the power z is equal to b, right? Then this other one can become c to the power x is equal to b, and then the final one can be c to the power y is equal to a. Doing this now, we can then do some more manipulation where we say, okay, we know c to the power x is equal to b, so you can replace it there. We can say, okay, a to the power z is equal to c to the power x, right? And then now what we can say is that we know c to the power y is equal to a, so we can have c to the power y z is equal to c to the power x, which just means x is equal to we can okay, let's say y z is equal to x, but then we make z subject to the formula, which is equal to x over y. But what is z? Z is log base a b, this one is log base c b over log base c of a. We have that there. That is a simple logarithm proof, right? And for most of the proofs that I'm going to show you for logarithms, this is how we're going to be doing them, except for one very confusing one that took me most of the semester to know. But I'm going to cut this video short now and then continue in the next one. But yeah, I hope so far things are making sense.